What if everything we thought we knew about the universe was wrong? When NASA launched the James Webb Space Telescope, it was meant to look back in time to witness the birth of the first stars and galaxies. But instead of confirming what scientists expected, it revealed something deeply unsettling. Within months of its first observations, Webb began sending back images that defied the very foundations of modern cosmology. Galaxies appeared in places and in forms they simply shouldn't exist. Structures that were supposed to take billions of years to form were already there, shining fully developed just a few hundred million years after the Big Bang. How could galaxies so large, so mature, exist in a universe that was still in its infancy? These weren't just minor errors or miscalculations. They were clues suggesting that our models of how the cosmos evolved, how matter condensed, how stars ignited, how black holes formed might be incomplete or even fundamentally wrong. The first deep field image Webb released, known as SMACS 0723, stunned the world. Within an area no larger than a grain of sand held at arm's length, thousands of galaxies filled the frame. Some of them were so far away that their light had traveled over 13 billion years to reach us. Yet they weren't primitive clusters of gas and dust. They were complex, structured, and eerily familiar. The deeper Webb looked, the stranger things became. Massive galaxies appeared where none should be. Black holes that by all accounts shouldn't exist yet were already devouring matter at the dawn of time. And chemical traces, spectral fingerprints hidden in distant light, hinted at processes that looked uncomfortably like the beginnings of life. What Webb was uncovering wasn't just beauty, it was contradiction. Each image seemed to whisper a challenge to science itself. What if the universe didn't grow the way we think it did? Some cosmologists now suspect that the early universe may have evolved faster than current physics allows. Others argue that our entire timeline of cosmic evolution might need to be rewritten. Whatever the truth is, one fact has become clear. The James Webb Telescope is no longer just a window into the past. It's a mirror reflecting the limits of our own understanding. So what exactly did Webb see? And why are its discoveries making even the most confident astronomers question everything they thought they knew? Stay with us. What comes next might change how we see the universe itself. When the first images from the James Webb Space Telescope appeared on NASA's servers, scientists didn't expect controversy. They expected confirmation. For decades, cosmology had built a coherent story as the universe was born. 8 billion years ago, galaxies slowly formed as gravity pulled matter together and black holes emerged long after the first stars. But Webb's infrared eye shattered that comfortable narrative. It detected galaxies that were not only older than expected, but impossibly massive, some almost as large as the Milky Way, just 400 million years after the Big Bang. According to the standard cosmological model, that shouldn't be possible. There simply wasn't enough normal matter, hydrogen and helium, to form galaxies that quickly. Something was missing in our equations. Researchers began to propose explanations. Perhaps early star formation was far more efficient than we realized, producing stars at record speeds from ultra-dense clouds of gas. Or maybe black holes formed directly from the collapse of gigantic gas reservoirs, skipping the normal steps of stellar birth and death. Each theory pushed the limits of physics, forcing astronomers to confront uncomfortable possibilities. And then, as if to add fuel to the fire, Webb turned its attention to black holes themselves, those cosmic monsters that feed on light and matter. It found them where none should exist, at the centers of very young galaxies, burning bright with activity. How could such enormous black holes, millions, even billions of solar masses, form so quickly after the universe began. The leading idea was that they were born differently, perhaps not from dying stars, but from colossal clouds collapsing directly under their own gravity. Others speculated that unknown forms of dark matter or exotic energy fields might have accelerated their growth. Whatever the case, Webb wasn't just revealing the early universe, it was unraveling it. Each new image made one thing certain. The cosmos had been busy far earlier, far faster, and far more violently than we ever imagined. And the deeper the telescope looked, the more it blurred the boundary between known and unknown. For the first time, the oldest galaxies didn't look like relics. They looked alive, pulsing with creation and destruction. It was as if the universe had skipped its own childhood and gone straight to adulthood. If that's true, then maybe the Big Bang was not a beginning at all, but a transition, one echo, in a far older cosmic cycle. But while Webb was rewriting the story of our cosmic past, it was also opening new chapters in the search for life beyond Earth. For decades, exoplanets' worlds orbiting other stars had been little more than faint shadows, detected only when they dimmed the light of their suns. Webb changed that overnight. With its advanced infrared instruments, it could peer directly into alien atmospheres, breaking down the starlight that passed through them into chemical fingerprints. And those fingerprints told a story few expected. Take the planet KT, orbiting a star about 124 light-years away in the constellation Leo. On paper, it was already intriguing, larger than Earth, smaller than Neptune, and sitting in the so-called habitable zone where liquid water could exist. But when Webb analyzed its atmosphere, it found something astonishing: traces of water vapor methane and carbon dioxide ingredients that suggest complex chemistry, possibly even biological activity. Then came the real shock hints of a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced only by living organisms, mostly tiny marine microbes. If confirmed, it would be the first true biosignature ever detected outside our planet. Astronomers were cautious, but the implications were enormous. For the first time, the question of extraterrestrial life wasn't a matter of faith or fiction. It was a matter of data. Webb also turned its gaze to other strange worlds. WASP-39b revealed thick clouds of carbon dioxide and water vapor, while the blistering planet WASP-18b showed atmospheric conditions so extreme they defied known models of weather and chemistry. Each discovery expanded the definition of what a planet could be and what conditions might allow life to thrive. Yet Webb's revelations didn't stop at distant solar systems. When it pointed inward toward our own cosmic neighborhood, it saw familiar worlds with unfamiliar eyes. Neptune, long the most mysterious of the outer planets, suddenly came into focus like never before, its icy rings shimmering its storms, curling like living shadows. On the small moon, Europa-Webb detected towering plumes of water vapor erupting through its frozen crust, a phenomenon confirming that beneath the ice lies a vast subsurface ocean, one that may contain more water than all of Earth's seas combined. Even tiny objects like the asteroid Chariklo astonished scientists. Webb found it had a ring system of its own, small, delicate, but stable, defying all previous expectations. It even detected water ice on its surface, hinting at dynamic processes still at work billions of miles from the sun. Each observation added another piece to a cosmic puzzle that seemed to grow faster than we could solve it. Was the universe teeming with hidden oceans, unseen atmospheres, and organic molecules waiting to be recognized? Or were these patterns just echoes, chemical illusions, shaped by conditions we barely understand. Webb was forcing us to confront an uncomfortable truth. Maybe life is not rare, but common, and it has been staring at us from every corner of the cosmos, waiting for the right eye to see it. As Webb continued its mission, something even more disturbing began to emerge: clues, suggesting that the universe itself might not be as symmetrical, as balanced as we were taught to believe. In one of its deep surveys, astronomers noticed a strange pattern. Nearly 2/3 of the observed galaxies rotated in the same direction, while only 1/3 spun the other way. At first glance, it might sound trivial, but in cosmology it's not. According to the principle of isotropy, the universe should look the same in every direction. There should be no preferred axis, no cosmic spin to the entire structure of existence. But Webb's findings suggested otherwise. Was it a statistical fluke, or evidence that our universe carries a built-in rotation, an ancient motion inherited from something even larger? Some physicists took the idea further, proposing that our entire cosmos might have originated inside a black hole. If that were true, the spin of the black hole that birthed our universe could have imprinted its angular momentum onto everything within it. Galaxies, stars, even the fabric of space-time itself. It's a radical theory, but one that could explain not only the strange asymmetries Webb has seen, but also the mysterious acceleration of the universe's expansion. After all, if our universe began as the inner region of a rotating black hole, what we perceive as dark energy might simply be a consequence of that inherited spin, a kind of cosmic inertia still playing out billions of years later. And if that's true, then the cosmos we inhabit is not a uniform sea of stars, but the interior of an unfathomable structure, perhaps even part of a cycle of universes, each one born from the collapse of another. Meanwhile, Webb continues to blur the line between observation and revelation. Its data have revealed so-called sleeping beauty galaxies, massive systems that inexplicably stopped forming stars just 1 billion years after the Big Bang. They flared into existence, then went silent. Dead galaxies in an infant universe that should have been bursting with creation. Why would that happen? What force could shut off star formation so early? Theories abound. Perhaps violent black hole activity stripped away the gas needed for new stars. Or maybe unseen cosmic events, mergers, collisions, or energy bursts triggered a premature cosmic death. Whatever the cause, these silent giants challenge everything we thought we knew about cosmic evolution. 3 years into its mission, the James Webb Space Telescope has not just deepened our vision of space, it has deepened our confusion. Every discovery seems to answer one question only to raise 5 more. Galaxies too old, black holes too big, planets too alive, and a universe that may not even obey its own rules. Perhaps this is what true discovery feels like, not certainty, but disorientation. For now, all we can do is watch as Webb keeps peeling back the layers of the cosmos, one strange revelation at a time. Because if the telescope has taught us anything, it's that the universe doesn't just hide its secrets, it rewrites them. So the real question is no longer whether we're alone in the universe, but something far more unsettling. What if the universe itself is alive, and we've only just begun to hear it breathe?